Hello everyone. Let me start with a question. Why does a piece of iron sink in water while a piece of wood of the same size floats? The answer lies in a fascinating concept called relative density. Relative density is nothing but a comparison. It tells us how dense a substance is when compared to water at 4 degrees Celsius. And since it's just a ratio, it doesn't carry any units. It's a simple yet powerful idea that helps us understand why some things float and others sink. Let's define it mathematically. The relative density, RD, is given as the density of the substance divided by the density of water at 4 degrees Celsius. In equation form, RD equals rho sub S divided by rho sub W. We can also define it in terms of mass. The RD of a substance equals the mass of the substance divided by the mass of an equal volume of water. Notice how it doesn't depend on the shape or size of the object, it's purely about density. Because it is a ratio, relative density has no unit. It is simply a number, a scalar quantity. If the RD of a substance is greater than 1, it is denser than water and will sink. If it's less than 1, it's lighter than water and will float. That's why kerosene floats on water while iron sinks. So the unitless nature of RD makes it very easy to apply in real life. Now, let's connect RD with density in different unit systems. In the CBSE system, where the density of water at 4 degrees Celsius is 1 gram per cubic centimeter, the RD is numerically equal to the density of the substance. In the C system, the density of water is 1000 kilograms per cubic meter. So, density in C units equals RD multiplied by 1000. This relationship makes conversions between the two systems very straightforward. Let's look at some examples. If the density of copper is 8.9 grams per cubic centimeter, its relative density is simply 8.9. If mercury has a density of 13.6 into 10 to the power 3 kilograms per cubic meter, its relative density is 13.6. Silver, with a density of 10.8 grams per cubic centimeter, has an RD of 10.8. So, you can see that in CBSE units, the relative density is directly the same number as the density in grams per cubic centimeter. Now, look at this table of substances. Coke has an RD of 0.24, which explains why it always floats on water. Pure water has an RD of 1, which is our standard. Heavy metals like gold and platinum have very high relative densities, 19.3 and 21.5 respectively, so they sink very easily. Everyday liquids like kerosene, petrol, and olive oil all have relative densities less than 1, so they float on water. This simple chart tells us so much about the floating and sinking behavior of materials in water. Let's solve a problem step by step. A solid weighs 50 grams in air but only 40 grams when immersed in water. We need to find its relative density. Step 1. The loss of weight equals the weight of water displaced. That's 50 minus 40, which is 10 grams. Step 2. Relative density equals weight in air divided by loss of weight in water. So, RD equals 50 divided by 10, which is 5. Therefore, the solid has a relative density of 5, meaning it is 5 times denser than water. This is exactly how we measure RD in school laboratories using a spring balance and a beaker of water. So, to wrap up, relative density is the ratio of the density of a substance to the density of water at 4 degrees Celsius. It's dimensionless, it tells us instantly whether something will sink or float, and it's extremely useful in comparing the heaviness of different materials. Whether it's explaining why iron sinks, why oil floats, or why ships are designed to stay afloat, relative density is the key idea. I hope this concept is crystal clear to you now. See you in the next session with another exciting exploration of physics.